So the wonderful beauty of antiderivatives is there's rules just like there were for finding derivatives. So if you're the type of person that likes to memorize rules instead of trying to think of it, go right ahead. And you'll probably end up memorizing these anyway because they're so gosh darn useful. Okay, so if you have some function that is a constant times a function, so it's like if you have c times x squared, this is just some constant here, the derivative is just c times the derivative or the antiderivative of your function. Okay, so it pulls out, and then don't forget that plus c. Same thing for here. If you have two functions, two separate things being added together, so like an x squared plus an x to the third, you take the antiderivative of the first function and add or subtract the antiderivative of the second function. So it just breaks apart, like when we were taking derivatives of functions. So it's f of x, or big F of x, plus or minus big G of x plus c. If you just are looking for the antiderivative of a constant, so if it's like 3 in our last problem, or even 2, or sometimes 1, the antiderivative is going to be kx plus c. Now this one's really important. So this is our anti-power rule, and this is only true in the case where n does not equal 1, because if you look down below, this is x to the negative first. This is not the same thing. You cannot apply a power rule in that situation. It'll ruin it. So don't do that. But it's very easy. It's just 1 over your n value plus 1 times x to the n plus 1, and then plus c. Write it that way because it makes more sense. Otherwise, it gets very confusing, but we can manipulate this afterwards. That makes it a little bit easier. So the next one is this 1 over x. If you think really, really far back to our derivatives, what function had a derivative of 1 over x? If you guys remember correctly, this is the natural log of the absolute value of x plus c. Now the question is, why do we need the absolute value signs? And the answer is because if x is negative, it kind of ruins the problem because you can't plug negatives into a log or something like that. So no negatives, so you have to have these absolute value signs. You have to have them. All right, the next function is e to the x. And unsurprisingly, the antiderivative of e to the x is e to the x. It's great. Next one is cosine. You guys know the antiderivative to cosine is sine of x plus c. The antiderivative of sine of x is negative cosine of x plus c. And you can remember this because what's the derivative of cosine x? Well, it's negative sine of x. We need to put a negative in front to make it positive. Right, the antiderivative of secant squared of x is tangent of x plus c, because what is the derivative of tangent of x? Well, it's secant squared of x. Next is the antiderivative of secant x tangent x, and we know that this is secant x plus c, because what's the derivative of secant x? The derivative of secant x is secant x tangent x. So I know the antiderivative of secant x tangent x has to be secant x with that plus c. All right, this one, if you remember all the way back, is clearly arcsine of x. Don't really need an e there, so I'm going to erase it. And the derivative of 1 over 1 plus x squared is arctangent of x plus c. So you have to remember the form of your inverse trig functions, and also you have to know your trig functions really, really well so you can go backwards. I mean, if you don't have them, it doesn't work so much. You need to have them memorized. And this is what I told you guys before, so hopefully you memorized them.